can be young, okay?
All right, so section 5.3 part 2 is on concavity. So we're going to talk about concavity. So if the graph of f lies above all of its tangents on an interval, then it is called blank. So let's think about what that means. So we're going to have two different things. We're going to have something like that. We're going to have something like that. We could actually have going downwards like that. Oops. Or so down, down. Okay, 4 different things, I guess. Shh, guys. Okay, so if we drew in all the tangents here, notice how the graph of my curve is below all of the tangents. Okay, this is called concave down. If I draw all my tangents on this one, my graph is always below all of the tangents. This one is also concave down. Okay, if you draw on all your tangents on the other two, oops, messed up on that one. The graph is always above. This is called concave up. Same for this. Okay, so if the graph of f lies above all of its tangents, we call it concave down. Okay, lies, graph of f lies, oh yeah, above, yeah, so up. If the graph lies below all of its tangents, it's called concave down. Okay, what gets really confusing is when you talk about the slope. Is the slope increasing or decreasing? That's what you're thinking. So notice here was my first slope, then it got less steep, less steep, less steep. So the slope was decreasing. Or more negative. Notice how this one's getting more steep, but it's getting more negative. So the slope is going down. The slope values are getting smaller and smaller and smaller. Okay, the easiest way to think of this is I always think of like my curves. So if I have something like this, so if I'm thinking of the curves, I think of my hand. So look at my hand back here. If it's like this, up, concave up. If it's down, down. So which part of your curve is concave down? It'd be from here to here. And then all of a sudden it switches up from here to here. Now do you guys intuitively see that? Down and up, down and up. Okay, so this is concave down and this one's concave up. All right. So the concavity test, it says if f double prime of x is greater than 0, then the graph is concave up. So that's basically the slope of the slope. So I'm saying, is the slope positive, like getting steeper or less steep? You know. Okay. The other one is concave down. So if it's negative, it's concave down. So that was positive. This is negative. The second derivative test, if I was only given the first derivative and the second derivative, you could tell what was happening on that graph. You could tell if there were maximums or minimums. So think about that. If I have a maximum, so something like that, don't draw it, but if I have something like that, so I know my f prime of c is equal to 0, and I know that it's concave up, then that means it looks like this. You have equal to 0, concave up. So that would be a minimum. For my maximum, I knew f prime was equal to 0, and it was downwards. It was concave down, so that would be a max. That's called the second derivative test. Now, the AP test does that all the time, and you freak out when you see it because you're like, oh my gosh, do I have to find what f is? Do I have to go back and figure out what my original function is? Because all I know is f prime and f double prime. And then they usually do these really weird functions, or they just give you numbers. Okay, so you're using the second derivative test to see if it works. So imagine if you had a table, and you knew at 0, f prime was 0, but f double prime was positive. It would say something like, at 0, is there a max or min, or none? So you'd think, okay, it's concave up, and it's equal to 0, so there'd be a minimum. So you know what I say? See what I mean? Okay, so Okay, no, an inflection point is the point on f of x where the concavity changes. So in my little sketch, notice how there was a definite point where you went from concave down to concave up. It's kind of hard to always find exactly where it is, you know, but you can usually kind of tell. That's called an inflection point. So point of inflection or inflection point. Okay, so number one, it says determine where the graph of f of x equals x to the fourth minus 6x squared is concave up, concave down. Find any inflection points and draw a graph. So f prime of x is 4x cubed minus 12x. F double prime of x is 12x squared minus 12. So points of inflection. I set this equal to 0. I pull out a 12. I get x squared minus 1. So it would be equal to 0 at 1 and negative 1. I think most people usually call these points of interest because maybe they aren't inflection points. Maybe there's something else, but usually they're inflection points. All right, now we're going to do the same kind of line trick we did before, but we're going to do it with double prime. I'm going to put negative 1 and 1. And I'm going to check in my factored form. So let me go ahead and factor into all of it. If I check negative 2, I get 12, so positive, times a negative, so it's positive. If I check 0, I get positive, negative, positive, so negative. If I check 2, I get positive, 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 so positive. Okay, I'm not going to do my arrows pointing up and arrows pointing down like I did before because now this is talking about concavity. It's f double prime. So what I do when I talk about concavity is I draw up, so a U, down, up. Make sense? Okay, so it's going to be concave up from negative infinity to negative 1, and then again from 1 to infinity. It's concave down from negative 1 to 1. My inflection points. I want to find what those actual points are, so at negative 1 and 1 I need to find the f value. If I plug in negative 1 and 1, I actually get the same value because I had x to the fourth and x squared. So it doesn't matter if it's negative or positive. It's going to be the same number. So I get 1 minus 6 plus 1, so negative 6 for both of them. Oh, wait. No. I was thinking minus 1. So what do we get? So 1 plus 1, so 2 minus 6, so negative 4. Those are your points of inflection. So it's negative 1 comma negative 4 and 1 comma negative 4. Okay, and then you could draw a graph. So you could draw a graph doing what we did before. So setting your first derivative equal to 0, finding the max and mins, and then labeling those inflection points as well. Okay, so I'm not going to do that, but you guys understand how to do all that. Okay, let me see if there's anything else that you guys need to know before your fall break. So same kind of thing here. Find your first derivative, find your second derivative. It says label all points of inflection, so those are max and mins. And your extrema is max and mins. Points of inflection, that's your second derivative. So find second derivative equal to 0. Max and mins could come from first derivative equal to 0. But they don't necessarily have to be, like you could have x cubed, where that's not a max or min. Okay, so 3, sketch a graph of the function. So I gave you a couple different values. I said you have to have the point. So these are points, 2 for x, 0 for y, 4 for x, 0 for y. So we have to have those 2 points. Okay, then it says your derivative is positive if x is less than 3. So from 3 over, your slope is positive. Let's write that. Slope is positive. F prime of 3 does not exist. The slope is negative if you're greater than 3. So slope negative. And then double prime of x is greater than 0 for all x values. Not, well, everything but 3. So what do you think is happening at exactly x equals 3? Any ideas? Yeah. It could be an asymptote. It could also be, it could be like a cusp. Yeah, so you could have an asymptote or a cusp. So let's draw an asymptote. It has to go through this point, and your slope always has to be positive, and it always has to be concave up. So how about something like this? See how the slope is positive and it's concave up? Do you guys understand that that's concave up? Okay. And then slope is positive and concave up. So how about something like that? See how that works? Okay, that would be a sketch of the graph. Okay, I think that's all I want to do. Yep.
So if it can make that part of a U, then it's concave up. If it makes part of an N.
Yep, if it makes part of a U, it's concave up. If it makes part of a, what did you say, an N?
Lowercase n.
Lowercase n, it's concave down.